These are video series on applications of artificial intelligence in business. In this particular video, we will look at machine learning. I am Ibrahim Kuşçu, the CEO of the Next Minds. In order to understand machine learning, it is important to understand the broader concept of artificial intelligence. Sometimes there is a confusion that machine learning is artificial intelligence. In fact, artificial intelligence is a broader concept. Artificial intelligence relates to data science. There are domains of artificial intelligence and there are various techniques of artificial intelligence. Machine learning is only one of the domains and sometimes using a different variety of techniques of artificial intelligence. Data science is a very important step before creating a model of artificial intelligence systems. Data science is basically all the tools and techniques that helps us to visualize, to understand, to clear, and to prepare the data for the AI systems that we are going to be using. This stage is very critical because most of the AI systems, especially narrow AI, they are all dependent on the data. The more representative your data is, the more clear your data is, the more well prepared your data is, the better the performance from your AI system will be. After understanding the relationship between data science and artificial intelligence, it is important to make a distinction between domains of artificial intelligence and techniques of artificial intelligence. Domains of artificial intelligence could be vision, robotics, natural language processing, but the techniques of artificial intelligence are maybe some simple statistical techniques, artificial neural networks with some algorithm, or genetic algorithms. Another area that we might be using machine learning could be in robotics. We might be creating robots that might be learning. For example, a robot might be learning by observing an expert how to perform certain tasks. These learning behaviors can be simulated using some of the machine learning techniques. Now, machine learning is totally different than deep learning. Deep learning is only special technique that is used in machine learning. There are other techniques that could be used in machine learning. In fact, any simple technique like statistical methods that could be used in machine learning, but also artificial neural networks or genetic algorithms. Artificial neural networks are enhanced by using deep learning methods. In the deep learning, some of the typical methods are some advanced use of artificial neural networks. So in summary, it is important to make a distinction between artificial intelligence, domains of artificial intelligence, and techniques of artificial intelligence. Machine learning is only a sub-area of artificial intelligence where we might be using machine learning in different domains of artificial intelligence with different techniques of artificial intelligence. And deep learning is also just an instance of machine learning, where we are using advanced neural networks to simulate some learning behaviors in robotics or in vision or in face recognition. After clarifying the core concepts about artificial intelligence, machine learning, and deep learning, we can now turn into studying machine learning in greater detail. Just to repeat, AI is a broader umbrella concept. Machine learning is a wide area of study of artificial intelligence. And deep learning, in turn, is one of the approaches to the machine learning. Machine learning can be used in different domains of artificial intelligence, and it can use many techniques of artificial intelligence. Deep learning is one of the techniques and approaches to the machine learning. There are many different types of artificial intelligence learning. For example, there is learning by doing, learning by adaptation, learning by examples, learning by observation, supervised learning, unsupervised learning, and reinforcement learning. In this video, we will be concentrating on the most widely used learning methods in artificial intelligence. That is to say, supervised learning, unsupervised learning, and reinforcement learning. Whatever the learning method we are going to be used, let's first go over a typical learning scenario. We will start with data. Data could be a past data, could be simulated data, for example, for reinforcement learning in an environment, or it could be real-time stream data. Whatever the data is, it is important that our data is representative of what we are trying our system to learn. It is important that data is very clean and well prepared. Data determines the performance of our AI system. Data is critically important, especially for narrow AI that we are using everywhere now in the applications of artificial intelligence in business or in our daily lives. Once we have prepared our data very well, then our job is to split the data into training and testing set. There are different ways of preparing the training and testing sets. One way is to randomly choose some of the subset of the whole data as a testing set and leave the rest as a training set. Now, we will separate this testing set from the training set because this is the set we will be checking the performance of our learning algorithm. After we prepare our data, training set and testing set, we will decide to use which algorithm we will be using as a learning method. In artificial intelligence, we can use a technique of a statistical method or neural networks or genetic algorithms as a learning model. After we decide about our artificial intelligence model, we will be feeding the training data to our system and checking its performance. Once its performance comes to a certain level, an acceptable level, we will say that our system has learned the training data. And then we will test this learned behavior on the testing data. Remember, testing data has not been seen by the learning algorithm. We have kept it separate. It is important that our learning method generalizes to the unseen data. That is to say, there is a learned behavior, but we want this learned behavior to be able to show itself in the testing data as well. So we are showing the testing data to our system, and then we will be expecting our learned model to show similar or better performance in the testing data. Now, learning and generalization is very, very important. The opposite of learning and generalization is overfitting. Overfitting to the data means that our system has memorized the data that we presented to it. Memorization of data is very dangerous for learning because we want our system to learn the relationship in the data or a hidden insight in the data that will solve our problem. We do not wish that our system learns all the data, memorizes all the data that we feed into it. Because if it learns just the training data, then it will not perform good in the testing data. That is, it will not respond in a good way to the novel situations. So learning and generalization is very important, and overfitting should be avoided in machine learning. Training and testing mechanisms and learning to generalize in artificial learning systems uses the same mechanisms that we face in our lives. For example, as a student, we get trained in the classroom and through the books, and then we get tested in the examinations. Our performance in the test shows how we have learned through the books and the lectures. Also, when we were young kids, we learned how to speak a language, and in the school we learned grammar. And after that, we are able to write formal letters. Sometimes good authors write literary books, and poets can write poems. There are other cases where artificial learning systems could be very useful. For example, in agriculture, there are robots that can collect the ripe tomatoes. These systems have been trained on other cases of ripe tomatoes many and many times. After they successfully perform those training tasks, then they are launched in the real life and in the agricultural lands. Finally, image recognition is one of the widely used business applications. For example, self-driving cars need to be trained under different situations of the traffic signs. Learning plain traffic signs are very easy, but self-driving cars need to recognize different traffic signs under different light system, under different background, or under different weather conditions. After they have learned all these different combinations of the situations where traffic signs exist, they can safely be launched into the roads, and then they can determine their next best action based on the traffic signs that they recognize on the sides of the roads. Let's now turn into some of the commonly used learning methods in artificial intelligence, namely supervised, unsupervised, and reinforcement learning. In a typical supervised learning scenario, the teacher is present. That is to say, when we have a set of data, the correct answer is presented to the learning mechanism. For example, if we are trying to identify a picture of a cat among the other animals given a picture, we would label this picture yes if it contains a cat, but no if it doesn't contain a cat. Imagine that we have millions of pictures of data, and then each of the data that we have in hand are labeled whether it contains a cat or not, as yes or no. So during the training, we present our learning mechanism with this labeled data. So it knows that a picture in hand contains a cat or not. So if it contains a cat, it is supposed to learn the features of a cat. For example, how tall is the ear? What does the shape of a cat look like, as opposed to the heads of the other animals? So during the training, when giving the correct answer, we would expect our learning behavior to learn these features from those pictures. But in the testing, we do not provide the correct answer. We would expect our learning mechanism to give us the correct answer. If given a number of pictures of animals, if our system satisfactorily gives us correct answer to identify a picture of a cat in a picture, then we would be saying that our learning mechanism has learned what is a picture of a cat in the given pictures of animals. Supervised learning scenario is used either to predict or to classify. For example, in the categorical data, whether there's a cat or a dog in a picture is a categorical information. So the prediction would be, for example, if one of the customers would be purchasing certain products, what would be the next purchase of this customer? For example, if this person is interested in electronics, given the behavior of the past purchases, we would like to predict. Our learning mechanism should learn to predict what will be the next purchase of this customer. For supervised learning, there are typical techniques of artificial intelligence. This could be some simple statistical techniques, for example, regression, nearest neighbor, etc. But artificial neural networks or genetic algorithms are also possible to use for supervised learning scenario. Let's now look into reinforcement learning. In the reinforcement learning scenario, there is an agent which is controlled by a machine learning algorithm. The job of the agent is to be able to perform a certain task in an environment. By trial and error, the agent tries to perform the task. But if it makes a mistake, then it is punished. But if it does perform the task correctly, then it is rewarded. The job of the agent is, of course, to maximize its reward and minimize its loss. There is an objective function which measures the performance of the agent in that environment. One of the good examples of reinforcement learning probably are related to home cleaning robots. They must have been at least trained not to bump into any objects around them or get stuck anywhere in a place that they are making cleaning. These kind of trainings are often done in a simulated environment first. In the simulated environment, they are controlled by a machine learning algorithm. They are rewarded if they do the task properly, and they are punished if they make a mistake. Then they are put into real world situation and expected to perform as good as they do in a simulated environment. Of course, this is not the only thing that they need to be trained. They also need to be trained for cleaning up different stuff. Another example for reinforcement learning is probably retail robots. Retail robots are also probably trained in a simulated environment, and then they are put into real world situation where they can identify objects, they can pick them up, and they can bring them from point A to point B. Similar to supervised learning scenario, we have an unsupervised learning scenario. In this case, we have large sets of data, but for each of these data, we don't know the correct answer. That is, we have rows of data, but we don't know what this data describes. In an unsupervised learning, it is very important to find out typical rules that describes the data or the patterns in the data. These kind of algorithms are very good in creating groups or clusters of related items. For example, in the supermarkets, related items are often shelved together. In one case, it has been discovered that whenever there is a sales of baby nappies, there are increases in the sales of beers. This was very unexpected. It is discovered that whenever there are single parents buying baby nappies, they also buy a couple of beers to drink when they are babysitting their kids. This was a very unexpected situation discovered through unsupervised learning that helped supermarkets to put those products together in order to enhance the sales. Unsupervised learning systems can be very good in building intelligent recommender systems. In this case, intelligent recommender systems can identify what will be the next potential purchase of a particular customer. For insurance businesses, it is important to cluster or group together different customers into different risk groups. Unsupervised learning can help to do this and also predict what will be the typical risk group of a potential next customer. There are different methods used for unsupervised learning. One of them is k-nearest neighbor, but the most important and most well-known approach is coherent learning or self-organizing maps. In this video, we talked about machine learning, an area of artificial intelligence. We started discussing different core concepts so that they are not confused with each other. We differentiated between artificial intelligence, a sub-area, machine learning, and then sub-area, deep learning. Then we turned into discussing typical learning scenarios in artificial learning environments, and then we gave examples of supervised, unsupervised, and reinforcement learning. Please do the activity that follows after this.